Welcome to the channel. So today's topic is GridSearchCV using Scikit-Learn library. So GridSearchCV is a method which is used for tuning different hyperparameters for machine learning models and to come out with best set of hyperparameters from a possible combinations and use that on those final set of parameters for training the machine learning model. So this is basically an option to find out best set of parameters among the available ones that we want to try out. So let's get started. You will understand it with the code. So import required libraries. So import pandas pd from Scikit-Learn preprocessing import not label binarizer, label encoder. Then from Scikit-Learn model selection import GridSearchCV. Then from Scikit-Learn ensemble import random forest classifier, extra trees classifier, and gradient boosting classifier. Okay, so these are the required libraries for this example. So I will basically tune the hyperparameters for these three machine learning models: random forest, extra trees, and gradient boosting. Okay, so next step is to load the dataset. So I want to use another dataset for this example. So it's called early stage diabetes risk prediction dataset. Okay, so let's load it. pd.readcsv. Let's just copy this big name. .csv. Then df.head. Okay, so this is the dataset for this example. Let's check the shape. So we have 520 samples and 17 columns, 16 features, and last one is the target column, which says class here. Okay, let's also check df.info. Okay, do you have any missing values? No, I don't think we have any missing values. So we have 520 for all the columns, non-null. So there is no missing values. However, we have a lot of categorical values in the column. So we can see object for the columns starting from 1 to 16, and only first column is integer. So we need to perform pre-processing to turn these categorical values into numerical values. So before that, let's just check the unique entities in our target column. Also, let's check the value counts. Okay, so there are two types of entities in the target column, positive and negative. Since this dataset is called early stage diabetes risk prediction, so I believe positive means there is a risk of diabetes occurring in a patient. Negative means there is no risk of diabetes occurring based on 16 features. So you can see these are all the features. There are different types of features here, and positive is present 320 times and negative is present 200 times. Okay, so now let's perform pre-processing to take care of these categorical values. Okay, so label encoder for I in df.columns object, then we'll apply the pre-processing dot fit transform dfi. Let's check first few rows again. Okay, now we do not see mail no yes type of stuff anymore. We see 1010 all numerical values. Okay, and let's just clarify once again. So now instead of positive and negative, I think we will get like 1 and 0 something. Oh yes, so now positive has been mapped with a value of 1, negative with 0, and these numbers are same for 1 and 0. Okay, so now we can separate features and classes. Okay, so features will be x, so df.iloc. Okay, so we have to separate our features and classes. Now let's apply grid search. CV in the first machine learning model. So I will apply grid search in 3 models for some hyperparameters. So first one is random forest. So random forest classifier. Okay, so let's call it random forest GridSearchCV. So estimator will be random forest classifier. Let's fix a random state and let's check the hyperparameters that it has. So it has n estimators, which is basically the number of trees, max depth, the depth of the trees, and there are many hyperparameters, but I do not want to make this problem very complex, so I will only tune this parameter and this parameter. So by default it says 100 and max depth says none, but I will select a few values. So param grid, so first one is n estimators. Okay, so it says by default 100, but I will not choose that big of a value, so I will use 2 trees, 5 trees, or 10 trees. And another is max depth. So max depth is by default none, but I am choosing 3 values. Okay, and there are other parameters as well which I am not tuning. So there is criterion, and if we look at the options for criterion, we can try 3 different options: Gini, entropy, log loss. But let's not go into that far. Let's keep it into 2 parameters, and we'll check all the combinations. So there will be basically 9 combinations. For this one, these 3 will be tried out. Similarly for this one, again these 3, again finally this one, these 3. So there will be 9 combinations in total. Okay, and we'll also use cross validation. Let's use 5-fold cross validation. Then let's feed our features and classes. Okay, it looks okay, yes. Okay, so this object gives so many things as output, but you can see from the start that it's basically a dictionary. So we can actually convert it into a pandas data frame, and we do not need to like look at everything. So let's say time. We do not need to focus on time right now. We need to focus on this because we have tried out options for this one. So these are all the combinations. I think we have 9, as I've told, because for each of these 3 will be carried out. Similarly for other 2. So we should have 9 options here: 3, 4, 5, 6, 7, 8, 9. Okay, and we will also consider these scores, which is the basically accuracy. So let's only focus on what should I call it, RF results maybe. So pd dot data frame rf dot cv results. So it will become a data frame. Then we'll access only a few columns. So we need param n estimators, then param max depth, then we need the accuracy, so mean test score, and rank test score. So rank test score. Oh, sorry, forgot. So this is the correct variable. Okay, so there are 9 combinations, and we can see that this combination has the best accuracy. It is 94%. Others are less than 94%, and lowest accuracy is probably this one. Okay, so by 9th, rank is 9th. Okay, so for 2 trees and max depth of 3, we got the lowest accuracy, and for 10 trees and max depth of 5, we got the highest accuracy. This is for random forest. Okay, and we can basically confirm it by calling this option best params and rf dot best score. So it just proves this best score is this 94% accuracy, and this is the best set of params. So we basically tuned 2 parameters and tried 9 options. More options can be tried, but I'm not making this thing lengthy. I'm keeping it short. So now let's focus on the second one is extra trees classifier. So think this one will be 6. Extra trees classifier. So I will copy this part and change this name. So etc change this name to, so this will be extra trees classifier, and it also has these two parameters. So you can see in estimators, max depth criterion, more or less similar parameters like random forest. So let's tune the options for these two hyperparameters, and I think we can just run this. Okay, again more copy paste. So instead of RF it will be now etc etc etc. Okay, so in this case too we got the best accuracy for 10 trees and a max depth of 5. You can see the rank is 1 here, and if the trees are 2 and max depth is, it is lowest accuracy, rank is 9th. But I think in this case this value is higher than this one. So this is 85% and this is 88%, and previously this was 94.6. now we have 95.2. Okay, so using extra trees classifier, the situation improved just a little bit. Okay, and let's just confirm with this. So now we have etc. So you can see this. Okay, so we have one more, which is I think gradient boosting classifier. Gradient boosting classifier. So this one also has these two parameters. So n estimators, you can see n estimators, and the max depth parameter. By default it is 3. I'm trying options of 3, 4, 5. So I intentionally chose these 3 models so that I do not have to make changes in this part. I can just copy paste. So I think you can just run it, then again copy paste. So in every case there will be 9 combinations because this part doesn't change. So 𝐺𝐵. Okay, so in this case we got a different outcome. So now it says we get the best outcome using 5 trees and a maximum depth of 5, and the accuracy is 95.96, almost 96%. So I think this is better than the other two. Here we got 95.2% and here we got 94.6%, but using 5 more trees than gradient boosting classifier. Okay, let's confirm with this one GPC. Okay, so we can see this one. Okay, so that's just individually doing these tasks. Now how can we do all of these together, not by doing individually? So let's just show that. So we can give it a heading such as applying GridSearchCV in all the models. So we can first create a list. Random forest classifier, random state 42. Then extra trees classifier, random state 42. So these are our models and these are the parameters that will be tuned. Params ticked. I'm not gonna type, so just copy. Okay, then another list is scores. Then we can just apply for CLF in CLFs. So basically iterate through these three options. Let's call it GS, GridSearchCV, CLF, then param grid will be params dict, cross validation 5 as usual. We feed the data, then append the best model after hyperparameter tuning using GridSearchCV method, and append a dictionary. So we'll append the selected model. So there are three models, so these are the three models. Then we'll append the best score obtained, and finally best params obtained. Okay, so let's show the outcomes as a data frame. So pd dot data frame scores, so these are the names of the column in the data frame. Okay, so does it match with these outcomes? So for gradient boosting classifier, 5 trees, max depth of 5, 95.96. Okay, 5 trees, and in other two cases I think there are 10 trees and max depth of 5. So we can see 10 trees and max depth of 5, 94.61. So 94.61 for random forest, 95.2 for extra trees. So we can see among these three, gradient boosting classifier is obviously the best model because it requires less number of trees. It's better than other two models. And it also requires the less number of trees, so 5 trees compared to 10 in case of random forest and the extra trees. Okay, so this is how we can perform hyperparameter tuning in machine learning models using GridSearchCV method. It comes with Scikit-Learn library, and I didn't tune many parameters. I only tuned 2 hyperparameters and compared 9 combinations between them. But there are many more parameters in all the 3 models that can also be tuned. You can try that out if you want, but I wanted to keep this video short and simple. So that's basically the end of this video. Thanks for watching.